Assalamu alaikum. This is a brief demonstration of the machine learning project for the course Machine Learning 2. Uh, The aim of this project is to gauge the performance of both Bayesian learning methods and the machine learning methods uh, and draw a comparison between the two. So I have selected three data sets. All three are of the binary classification problems. So first dataset is the inventory demand dataset, which has the sold flag as the target variable. These are the important libraries along with the template which I have designed specially for this project. It consists all the important functions which are needed to perform a data analysis and machine learning tasks. Coming back, so this is the data set, brief overview of the data set. It contains 14 columns and almost 200,000 rows. So these are the missing values. So for this problem, we have to predict the stored flag, and it is important that null values from this target variable are removed. So therefore, I have selected the only those rows where this flag is present, and everything else is clear with regards to missing values. So continuing, this is a brief overview of the dataset. Uh, this order column is unnecessary as it is basically a unique identifier, so it has been removed. Similarly, the SKU number and file type is also not relevant. So this is the situation of the target variable, and as we can see, it has a massive class imbalance. Therefore, the F1 score and the recall score will be of ultimate importance. So this is a brief EDA of the dataset. Uh, as you can see, there is exists a skewed distribution for the item count. Similarly, for price, this and then I have done the statistical tests, the chi-square test to determine if the uh, the non-numerical, the categorical variables have a relationship between with the target variable. As you can see, uh, the both marketing type and the release year have a effect. However, new release flag does not. And similarly, I performed the ANOVA test for the continuous variables, and all of them have show a positive relationship. And then I performed clustering on the dataset, so to get a brief idea of if any clusters exist. So K means plot has been plotted, the elbow plot, and it is giving a score of the SI score of 0.84, which is quite good. Uh, Here are the seven clusters visualized in 2D using TSNE dimensionality reduction method. DB scan and hierarchical clustering algorithms failed due to insufficient memory. Similarly, bean shift has generated 9 clusters. It is also giving a very good score. Uh, Same is the case for GMM. All clustering algorithms are giving good scores. In order to give a concrete meaning to the clustering results, I have plotted the 3D plots over here. So as you can see that, well, nothing conclusive can be deducted from the, uh, in regards to the item count. However, the price is also were more or less the same, so nothing conclusive can be deduced from this. Coming on to the machine learning part, which is of utmost importance. So there are no highly correlated features in the dataset. So sold count is the variable which is important after the analysis, after the prediction of the binary variable. So it has been removed. Uh, Performing further data cleaning and test and split, and then I have employed the random forest feature importance algorithm to check which features are important. So after the results, it has been confirmed that new release flag is of no use, as chi-square test also suggested, and the random forest algorithm has also concluded. So I have performed various. These are the machine learning algorithms which I have performed on this dataset. Well, nothing inclusive came. The performance was extremely poor with respect to the F1 score for all algorithms across. So basically, it is a highly skewed data set, so it was expected. Coming on to the algorithms with random forest feature selection, uh, more or less same results ever achieved with a very poor performance of 0.24 for the F1 score, 0.28, which is very poor. So this is a brief summary of all the algorithms. Same was the case for cross-validation with random forest feature selection, oversampling with without random forest, with random forest. So all of these different combinations have been performed, but none of them gave concrete results. The best results to achieve were from the random forest with the 69% FS1 score of cross-validation. However, the performance of this particular algorithm on the test data deteriorated very badly. Then I had performed LDA. Since it is a binary classification task, therefore it generated only one feature, and all the algorithms were again run on this new data frame of by the name of LDA data frame. However, none of them were able to perform. Similar results over here also, 0.27, 0.24. See, it is all the algorithms have failed on the LDA data frame. For the PC, I have performed the cross validation and selected the number of components. So, as the graphs say, F1 score of 0.16, it is very bad. Recall score of zero point 0.1 for each and every algorithm. So it can be concluded that all the ML algorithms have failed badly on this dataset. So coming on to the MCMC methods, the Bayesian learning methods, I have basically draw the pair plot with the diagonal kind of kernel density estimation. So as the pair plot suggests, the item count and marketing type are the two variables which are able to distinguish a bit the sold flag. So I will select both these features for the Bayesian analysis. Firstly, I have done the sold flag. I have centered around the mean, performed test train split, and then trained the model using PyMC3. This is basically these are the priors from the normal distribution. This new value is the deterministic. Uh, will be used for the deterministic theta value, which will then be used to determine the YL value, which is the prediction from the model. And observed is the Y train, and it will be sampled for 1,000 per chain. It will be sampled for 1,000 times for each chain. So this is the summary. Since R hat value is 1, therefore it can be concluded that the chains converged. So as the R hat value suggests that the chains have converged, and similarly the trace plots also confirm since they are symmetrical in nature. Therefore, it can be concluded that the chains have converged. Here are the posterior plots for the different variables. So this is the posterior predictive check, and it gives a very nice distribution as the observed values and the posterior predictive values are all aligned with each other. Okay, so this is the trace plot. So generating data for the test set. Over here, I have used the XC test in place of the XC train and generated the sample posterior predictive. And these are the values. Okay, so the length of this array is the number of test samples, and the number of rows is the number of samples generated. The mean will be taken across the columns to generate prediction for each data point. These are the predictions, and I have set the threshold value of the point 0.5, which is the default for logistic regression. And so here are the results, very poor results as of now. Similarly, further attempts were made using the student's t distribution in place of the normal distribution, as theoretically the student's t distribution has wider tails, which account for the skewness of the prior, which is the item count. Okay, so similar process has been done, similar results, and equally poor results. So, and then I have used the Metropolis Hastings algorithm. Uh, However, it shows a bit of divergence as the R hat values are not one, and the trace plots also confirm this. Therefore, we can comfortably reject this. Nuts has performed better than the Metropolis Hastings. So I have now selected both item count and marketing type as the variables. A similar process has been repeated. R hat value 1, but the overall accuracy is very poor. So is the F1 score. So I have this time I have used the hierarchical approach. These are the hyperpriors for the prior of beta, and beta has been generated from the Laplace distribution. And similar process I have generated. Okay, so since there was lack of available RAM, the plot of trace plot was not able to be generated. So generating predictions, and we have an F1 score of 0.02, which is very poor. Okay, so now I have undersampled the majority class and then repeated the same process with the hierarchical approach. And this time I have reached very well better results as compared to both machine learning and the previous attempts of Bayesian learning. So it can be concluded for this dataset, Bayesian learning using an MCMC method is the go-to approach, as I have an F1 score of 63, which is far better than what was achieved through the machine learning algorithms. So the second dataset is the credit card fraud dataset. It contains of 31 columns. The target is the class, the column of class which is a binary column, zeros and one. One represents a fraud transaction. The rest of the columns are basically principal components, as the original data set has been reduced using PCA. Removing all the columns do not have any missing values. Time column is irrelevant, it has been removed. A similar EDA, as you can see, the class, a massive class imbalance, only 492 fraud transactions. ANOVA tests suggest that the amount is significant in determining fraud. Performing similar clustering, however, the elbow plot did not converge. So therefore, I have not done the clustering, as it is not suitable to generate so many clusters in a data set. Okay, so coming on to the machine learning part, no correlation whatsoever, and understandably because PCA has been done, which removes any correlation present. Similarly, I have generated the random forest feature importance values, and now performing the ML algorithms. Uh, the results were overall okay, because F1 score of 0.86, 0.88. So it has ML algorithms are working quite well on this data set. Similarly, over here also 0.87, 0.86, which are very good for ML algorithms. Different approaches with cross-validation, random forest feature selection, oversampling, undersampling, all were performed on this dataset, and they generated quite good results. However, using the MCMC methods was quite difficult, rather impossible due to computational constraints, as I was only able to sample 200 chains, 200 samples for each chain, due to limitations of RAM, and naturally the chains were quite bad and did produce very poor results, as you can see over here. Nothing. So, due to computation limitations, I was unable to perform MCMC methods on this data. So coming on to the predictive maintenance data, similar type of data where I have to predict the machine failure. So these columns are to be predicted after the machine failure. So these are irrelevant for the analysis. Uh, Brief EDA of the columns. Class imbalance exists as always with the previous data sets. So the chi-square test was performed, and it shows a dependence on the type of the machine, on the type of the quality with the machine failure. Column names have been changed to uh, with to make it easy for analysis. ANOVA test also confirmed that all columns are statistically significant in numerical encoding, categorical encoding basically. See, the mentioned columns have been removed. These functions have been imported from the template file. Performing clustering, uh, the k-means clustering algorithm failed. Performing the mean shift algorithm, it gives well poor result as the SI score is quite low, but nonetheless, just for analysis, I have performed the clustering. Coming on to machine learning, similar approach of random forest feature importance selection, and then performing the algorithms with different cross validations, random forest feature selection, oversampling, undersampling, all the possible methods. Uh, Results were quite good. Uh, well, not exactly very good, but better than the results achieved on the inventory demand data set. Then I performed LDA since this is a binary classification problem. LDA gave very poor results. Then I performed PCA where I plotted the PCA graph for different components, and very well, it was expected that PCA would perform good over here. However, PCA has proved very a waste of time. Then coming on to the MCMC methods. I've plotted the pair plot with the KDE as the diagonal. And so the torque and tool where features have a distinct distribution for the failure and non-failure. So I have selected as an initial analysis, I have selected these features. I have selected tool where centered around mean, perform test and split, a simple model, and generated the trace plot, the positive predictive plot. The function has been imported from the template, and the generations I've generated the predictions, but these were quite poor. So then I used the students T distribution. However, the results were still very poor. Similar results with the Metropolis Hastings, nothing. Then I used the hierarchical approach without dealing with the class imbalance. So the results were quite better. However, the F1 score is still poor, 0.42. Then I've undersampled the majority class, then performed the similar hierarchical approach uh, using hyperpriors. However, as we can see over here, the F1 score is very good as a result of the undersampling, and so is the accuracy. So for this dataset also it can be concluded that the MCMC methods are better as compared to the machine learning algorithm method. And here is a brief summary of the results that have been achieved up till now.